For the hackathon, you will work on a problem that is cracking the Enigma encrypting system. Enigma was a tool that was designed by Germans during the World War II, and it was broken by a well-known computer scientist that you already know. And the Enigma principle is it works like this. You press a key here on the keyboard, and then it will follow a path here, down, and then come back to another key. And so when you will press B, you will see A as the result. And this is the way you encrypt a message. And then, of course, there is a way to decrypt the message by following the reverse path. And this machine is composed of rotors. Okay, there are 3 rotors, and there is 1 reflector here. So the rotor is really the building block that you need to implement if you want to break the Enigma machine. A rotor is a mapping from some positions to other positions. And so it's a one-to-one mapping, like this one, okay? The 0 is mapped to 2, the 1 is mapped to 0, and so on. And the mapping table is given like this. And so if I give you an input I, the output is T of I, okay? And the way you model this in constraint programming, assuming this is a variable, so if this is a variable, this is called an element constraint. An element constraint is a constraint in which you index a variable by, you index an array by a variable, and you get as a result another variable. Okay, so this links everything together. This is called an element constraint. But the Enigma machine is slightly more complex than this because the rotor is rotating. And so the mapping table, after each step, for each input that you will encode, will slightly change. And the way it will change is that there will be a shift of the connection. You see that this connection well, this is the correct one. So every time you press an input like this one, the input 0, after that there is a change in the connection, and so they went like this, and so this one is now back at the beginning, and this is what you see here, okay? And again, after that, after you press the input 3, which is mapped to 4, this is what you get here. Again, there is a shift down, and you see that now this horizontal line is here, and so there is really a rotation. This is why it's called a rotor. How do we model that in constraint programming? It's even more complex because the mapping is changing depending on the step that you will have. And so clearly, you will need something like a 2-dimensional mapping table, something like this. And probably you will index it with the step and also with the input. And this is not the only thing, because if the message is larger, that you need to encode is larger than the number of positions, probably you will also need a modular operation. And these are all the constraints that we will study in the subsequent videos. I don't tell you more because it's part of the exercise to create the model.